Most researchers think our current models of the cosmos still give us the best explanation for how the universe started. This idea basically says that stars and planets formed, which eventually led to life like us. The Big Bang, as weird as it sounds, tells a cool story about what might have happened way back when. At first, all the stuff in the universe was squeezed into an itty-bitty spot, smaller than a pinhead, where everything was super squished. Then, bam, a huge burst of stuff. And energy, the Big Bang happened. This started the universe's expansion billions of years ago. But now, we know more about space, and the old Big Bang theory has some holes. The James Webb Space Telescope, JWST, they call it the biggest, bestest space telescope ever, was supposed to back up the Big Bang. But guess what? In just 1 year, it found stuff that made scientists' jaws drop. This telescope sees so far back that it spotted galaxies from super early times, which messes with what we thought we knew. Now folks are arguing about whether stuff existed before the Big Bang. One big deal was when a cosmologist, Rohanatu, spotted one of the first galaxies formed soon after the Big Bang. People flipped out. That showed how awesome the JWST is. It's still finding new stuff. It's maybe clues about the universe's early days. This time period fits loosely with the old ideas. It tells us how the first stars and galaxies got here. The JWST's finds are already clashing with old models. New galaxies have stuff scientists thought was impossible back then. This boom in early galaxies is making experts rethink everything, asking big questions. Besides its super discoveries, the JWST is in a great spot, about 1.5 million kilometers away from earthly junk, and super cold thanks to its giant sunshield. Its gold mirror and gadgets can see into corners of the universe we couldn't before. The time the telescope is showing us, which they call cosmic dawn, was about 200 to 300 million. Years after the Big Bang, that's when the first stars and galaxies blinked on. But nobody really knows how it all happened. There are ideas about dark energy, dark matter, how gases and dust interacted. The JWST can see galaxies from this time, so scientists can test their ideas. By studying these galaxies, they can see if their theories hold up or if they need to come up with something new. At first, they thought the JWST would only find a few early galaxies, but it blew those expectations away. The first pictures showed tons of galaxies, all different sizes and brightnesses, way more than expected. This has started a race to figure out what the earliest big galaxy really was. The findings keep coming, surprising everyone. The public are wowed by the complexity of these galaxies. Some scientists think there might be some mistakes in how the telescope works, but most agree these finds will change how we see the cosmos. It's a look into a universe that might be way more complicated than we thought. The JWST is asking big questions about what we believe about the universe. Some think we can fit these new things into our old theories. Others think this is a sign of something way more mysterious than we ever imagined. The big question remains, how did the universe become the nice, orderly place we see now out of that crazy beginning? The telescope's first finds might change how we see the Big Bang and give us new ideas about galaxies. Maybe they'll even change how we see our own galaxy, the Milky Way. Mark McFadden from the European Space Agency said it best. The point of building telescopes like the JWST isn't just to prove what we already think. It's to question and maybe break those ideas. The idea for the JWST came about in 1985, before the Hubble telescope even launched. Weir was asked to think about what could come after Hubble. He and a team worked on the ideas that became the JWST. Hubble takes pictures in visible light, but the JWST uses infrared. This is important because light from faraway galaxies gets stretched into the infrared range as it travels to us, making it invisible to telescopes like Hubble. The JWST's cold mirror can see these signals, which lets scientists see further back than ever before. The need for this telescope became clear. In 1995, when Hubble took a picture of a dark spot in the sky and found tons of galaxies, this showed how packed the early universe was and pushed for a telescope that could see even further. After a lot of planning and about $10 billion, The JWST launched on December 25, 2021. By July 2022, it was ready to go. Programs were set up to search for the earliest galaxies. The first guesses weren't even close. The first results blew them away. JWST findings have tested and even broken old ideas about the early universe. This reminds us why it's so important to explore and invest in technology. With each new set of information, we are close to changing everything we thought we knew about space. When the first data came in from the JWST, everyone was excited. Scientists who had spent years getting ready could finally their tools. Instead of waiting for the usual reviews, many scientists posted their results quickly. It started a lot of quick discussion, especially on social media. The experts giving opinions often in real time. Cosmologist Rowan Nodtu called it science by press release because of how fast and public the discussions were. While this made things faster, some worried about how well the science was being checked. Klaus Pontoppidan, a project scientist for the JWST, said that while quick sharing helped, it could also mess up the usual careful process. These big finds made workflows difficult, but researchers agreed it was worth it for the new knowledge. Right now, the Big Bang is still the main idea for how the universe formed, including stars, planets, and life. Even though the name is weird, the Big Bang theory explains how everything came to be. In the start, it was a small point from which a big eruption happened, pushing the universe outwards. But as the JWST looks deeper, it's finding the first limits of that original theory. The new galaxies forming too early suggests the story of how our universe came to be may not be complete. These findings are changing how we see the Big Bang and opening new paths for looking at every basic thing in space. The JWST's finds are already clashing with old models, showing galaxies with properties scientists didn't think possible so early on. This increase in early universe galaxies has made experts excited and made them rethink current ideas. As they look at this data, they're facing big questions about the universe's structure and the forces that controlled its early days. Besides its finds, the JWST's location gives it advantages. It's about 1.5 million kilometers from Earth, away from our interference and kept at super cold temperatures with a giant sun shield. Its big gold mirror and sensitive tools were made to see into parts of the universe we couldn't see before. The telescope is showing us the cosmic dawn about 200 to 300 million years after the Big Bang. This is when the first stars and galaxies started to shine. But how this happened is debated, with ideas about dark energy, dark matter, and how star-making gases and dust interacted. The JWST's ability to see galaxies from this time gives scientists a chance to test or change their theories. By studying these distant systems, they can check their ideas or find problems that could lead to breakthroughs. At first, expectations for the JWST were low. Scientists thought it would only find a few faint early universe galaxies. Surpassed those expectations. The telescope's first pictures of the ancient universe showed many galaxies, different in age, size, and brightness, more than expected. This flood of early galaxy data has started a race to redefine what the earliest big galaxy is. Finds keep coming in, surprising even experienced scientists as the JWST's observations pile up. Scientists and the public are amazed by the complexity of these new galaxies. Some scientists think that problems with the telescope's observations might explain some strange things, but most agree that these finds are changing our view of cosmic history. These clues give us a look into a universe that might be more complex than we thought. The new evidence about these ancient galaxies, thanks to the JWST, raises serious questions about what we believe about the universe. Some scientists are hopeful that these strange things can fit into current ideas, while others think they might be the first signs of a more mysterious universe. The big question remains, how did the organized universe we see now come from the chaotic early days? The telescope's early finds might change not only how we see the Big Bang, but also how we understand distant galaxies, and maybe even our own galaxy, the Milky Way. As Mark McFadden from the European Space Agency said, the point of making tools like the JWST isn't just to confirm theories, but to challenge and maybe break them. You never know what might be overturned. The idea for the JWST goes back to 1985, for the Hubble Space Telescope. At that time, Gar was asked to imagine what would come after Hubble. Despite skepticism, Weir and a team laid the groundwork for what would become the James Webb Space Telescope. While Hubble took pictures in visible light, the JWST was built to work in infrared. Now, this is important because light from distant galaxies is stretched into the infrared range, making it invisible to telescopes like Hubble. The JWST's big, cold mirror can detect these signals, letting scientists see back to a time closer to the universe's beginning. The need for such a telescope became clear in 1995, when Hubble's deep-field images showed many galaxies in what seemed like an empty area. This showed how crowded the early universe was, and the need for a telescope with more reach. After years of planning, development, and about $1 billion, the JWST launched in December 2021. By July 2022, it was ready to start its important science work. Research programs were set up to find the universe's earliest galaxies. Initial predictions were careful, but the telescope's first data quickly went beyond them. JWST observations have already started to test and sometimes overturn old ideas about the universe's early days. These finds are a reminder of why it's important to explore and invest in advanced tools. With each new set of data, researchers are close to changing what we thought we knew about the universe. When the first data from the JWST came in, the excitement was high. Scientists who had been preparing tools and models for years could finally use them. Instead of the slow, traditional review process, many researchers quickly published their findings online, allowing for fast access and criticism. This started quick discussion, especially on social media like Twitter, where experts could give their opinions in real time. Cosmologist Rowan Natsu called this science by press release, noting the speed and visibility of the discussion. While this openness allowed for fast feedback, some scientists worried that it might hurt the thoroughness of scientific checks. Klaus Pontoppidan, a project scientist for the JWST, warned that while this fast sharing allowed for quick teamwork, it also threatened the careful process that usually defines science. The flood of major finds from such a big project presented new problems for traditional ways of working. But most researchers agree that these problems are worth the knowledge being gained as it stands. The Big Bang model is still the main explanation for the formation of our universe, including the start of stars, planets, and life. Though the name might be strange, the Big Bang theory gives a clear science-backed story of how everything came to be. At the start, the universe was a tiny, dense point where particles were crammed together. From this point, a huge eruption of energy and matter happened, starting the expansion of the universe we see now. But as the JWST looks farther into the past, its finds are starting to show the limits and gaps in the original theory. The discovery of galaxies forming too early suggests that the story of our universe is not complete. These finds challenge the Big Bang and open new ways to understand the basic rules that shape everything, from atoms to galaxies.